Good morning. Thank you for inviting me to speak. I am going to cover also some bad news, but we will move through it quickly in order to get to some really core principles that I think will build on some of the things that Dan was talking about this morning. And then at the end, I'm going to do a fun little experiment. So whoever's monitoring the time, I hope that you save 5 minutes for an experiment at the end that will illustrate these topics. I run a nonprofit that's based here in Marin County called Socentric, and our mission is to accelerate engagement in regenerative agriculture. Laura asked me to talk about the soil carbon sponge. So I'd like to connect some of these principles to what you can do in your neighborhoods and in your gardens so that we can mitigate some of these problems. All right, so quick review. We all know about this famous Keeling Curve, but what I'd like to point out that I think maybe hasn't been pointed out to a lot of people is that the problem and the solution are actually in this same graph. So, whoops. So you see that line going up about our CO2 atmospheric concentrations, and we've crossed 400. We know we're supposed to stay below 350, but you see the red squiggly lines? Yeah. Those are actually what's called the interannual fluctuation, and that is actually the Earth breathing. So that is photosynthetic activity at a global scale every year, drawing down carbon when the great forests leaf out in the northern hemisphere. And it's actually such a large photosynthetic drawdown that they can measure it. And so that's why it goes down, and then it goes back up again when the leaves fall off. And then nature does its whole thing again, goes into dormancy. But I point that out because the Earth that Dan showed us, the beautiful blue marble, is actually a living, breathing system. All right, but we have hampered this system because as humans, we've, this is, okay, so photosynthesis, we know that this is what removes atmospheric CO2. But we have cut down 50% of the trees on this planet since civilization began, and that's kind of like walking around with one lung. So, we have a huge opportunity because we not only know that that's a huge problem to cut down 50% of the trees on the planet, it's also we can revegetate, and there are all these initiatives now. Why is this moving and I'm not touching it?
I don't know.
Sorry.
Let me.
It's just on its own. It's on its own.
It's on slideshow or something.
Well, anyway, so there are all these initiatives now to reforest the planet, and I think that's very, very hopeful. So one of the things.
So is that the next one?
No, it was back. Okay. So what causes the soil to lose carbon? And the soil holds incredible amounts of carbon. I mean, there's like, I forget the statistic for it, but it's like 5 times the amount of carbon in the soil than there is in the atmosphere. But we have been degrading the soil. It's not all our generation's fault. Humanity's been doing this for centuries. Plowing, overgrazing, burning, deforestation, erosion, draining wetlands and bogs and so forth. But as I said, that means there's a huge opportunity to reverse these trends. And one of my favorite books, if you are interested in sort of studying this over time, is a book called Dirt, the Erosion of Civilization, and you will see that civilizations pretty much systematically have done this forever, except for the Egyptians, who were pretty lucky because the Nile would flood and bring back all those nutrients to their floodplain every year. But what has happened with this erosion, with this soil, with the carbon leaving the soil and going where it's a solid and going up into the atmosphere where it turns into a gas, is that we've interfered with the hydrology of the Earth. And that's a really big problem, but again, something that we can address by thinking about it a little differently. So pedogenesis is kind of a fancy word for the formation of soil. And this is what makes our planet what it is. We're the only planet with this living soil ecosystem. And when that living soil ecosystem is functioning properly, it's like a giant sponge, okay? We all can picture a dried out sponge versus a wet sponge. And so we want our soil sponge to be moist. And when it's in the sponge form, it looks like a sponge. It has lots of little holes and pores so that the water can infiltrate and so that roots can come down and so that all sorts of microbiology can live in the soil. It used to be that people thought that it took 500 years to form an inch of topsoil. That's the weathering of rock. That's what takes 500 years. But now scientists are realizing that if you look at the biology, we can actually build soil very quickly, and that's the promise of regeneration. So that when you put the biology and you have the hidden half of nature that we can't see, those microorganisms that live in the soil, those nematodes and bacteria and virus and all those different things, and then your bigger orders like earthworms, they can form soil quite quickly. Okay? So we need to look at soil carbon as a resource. If you think of atmospheric carbon as a problem, right? When carbon is in its gaseous form as CO2, it's a problem. But if we have it in the soil where it's a solid, it's actually doing nothing but good. Okay? So you may have heard of the Marine Carbon Project. There are all sorts of exciting things happening right in our own county where they show that compost application on rangeland will increase soil carbon capture. But here's a concept I want you to think about, that water follows carbon, okay? So when you have carbon in your soil, the water's going to follow it. And here, that's a picture of me in Greece. I went to visit this young farmer named Dimitri, who, I think this is really interesting because here's the cradle of civilization. This is right outside of Athens on an island called Evia, where it's so degraded. It's just crazy. It's 1,000,000 degrees and nothing's growing. And this young man with his family bought 5 hectares and they just started planting things. And when you give nature just a little bit of encouragement, she responds. And so now he's been planting all these, he's got an agroforestry system and he's bringing back the water, he's cooling the landscape, he's growing food, and he's providing habitat. So this is a concept that, again, is really quite simple if you think about it, and it's the concept of effective rainfall. So in a system, what you want to do is you want to capture the rain that does fall. And sometimes rain will fall, quite a bit of rain, and it will just, maybe fall on the parking lot, and because that surface is impermeable, it'll just run off into the gutter. That's not effective rainfall, right? That is not effective. None of that is going back into the system. So when you do have rain, you want your raindrops to go back into that soil carbon sponge. And how do you do that? Well, you change your management practices. So you encourage that water to stay in the system. And things like compaction and paving discourage effective rainfall, okay? So you think about an effective system, a wetland is an effective functioning sponge. And over time, humans have drained wetlands because that's where the really great soil is, because there's so much decomposition happening there. But we don't want to drain any more bogs or wetlands, okay? So when you have non-effective rainfall, it leads to drought and to flooding. They're both actually examples of hydrological extremes where the system isn't functioning. Because in a flood, you have a lot of water, but none of it is going down into the soil sponge. If it were, you wouldn't have the flood. So think about this for a minute. If you increase the organic matter on an acre of land, this is an NRCS statistic, that acre can hold approximately 27,000 additional gallons of water, right? And so this is the kind of stuff that Marine Carbon Project is showing. Like, you put a little compost, a little topsoil, you give nature a little encouragement, and the water follows the carbon. Okay? I think it's funny that Dan and I both picked slides from the Carrizo Plain. This is wildflower bloom last spring. Those are some baby blue eyes. And the reason I put this slide in is because I want to point out the importance of decomposition in the formation of soil. So you see the beautiful baby blue eyes, but in the middle there's some oxidized vegetation, all right? And it's about this high. And that is actually a huge problem because it is impeding photosynthetic activity, right? And it's also standing matter that could catch on fire. So when the system had more animals, so you'll see that climate change and biodiversity loss and all these things are interrelated, the antelope would have grazed that vegetation and there wouldn't have been any standing matter, okay? So even in a beautiful place like this, you know, we have the absence of the flora and the fauna causes problems for the native plants. All right, so decomposition is a really important factor in the soil carbon sponge. And decomposition can occur in several ways. You've probably seen Fantastic Fungi. If you haven't, it's a great movie. But fungus is very helpful in this decomposition process, right? So everything lives and then it dies and then it decomposes and then the life cycle starts again. But the question is, how does it decompose? Is it going to be oxidized matter standing there on that, you know, hillside? Is fire going to come through and burn it? Or is the fungal activity going to decompose it? So we want to, land management practices can incentivize the fungal networks to decompose things more quickly because fire, you know, can be a tool, but it also can be very dangerous now when we have extreme